Welcome back. Next up we've got Phil Ingram talking about ops from bare metal to cloud space. And if people have questions, we're going to actually try to run the microphone around to people so that they get picked up by the video. So yeah, stick your hand up and we'll sort that out. And if anybody's seen Kim Horton or John Dickinson, they're up after Phil. So
yeah, I don't think Kim's too far away. I was talking with him before, so. Cool, thank you very much. Before we get started, any remote rocks, and there is actually now an Android app for it, so you can control things and move around. Hopefully it works. So anyway, welcome ladies and gentlemen. This isn't going to be a hugely technical talk, so there's just really going to be a bit of food for thought. So it's kind of targeted towards people who are either thinking about or who have just made the transition to infrastructure as a service. There are a few really important points to consider, so I'll go through some of the big ones and go through, I suppose, give you a bit of inside knowledge without hopefully getting myself fired on how Acquia deal with these challenges and what we've done to overcome them. So myself, my Linux days started back with Mandrake 9. I managed to kill my install in about 20 minutes and had to reinstall. That was fun. So I've been playing Linux on and off, and back in 2005, landed the first IT job as a sysadmin, running a network supporting about 160 clients, which is where I cut my teeth on the LAMP stack, originally running Moodle. Did a bit of virtualization work and eventually got my RHC in 2008, and from there, in May last year, I was lucky enough to get a job with Acquia as a cloud system engineer, working in the operations department, so helping to manage, maintain and deploy our current fleet of over 3,800 servers. It's just a couple. So just a bit of background about Acquia. Our product is Drupal. We were founded by Dries Buytaert, who, for those who don't know, was basically, he created Drupal and has grown to be the product that is today. Throughout this talk, I'll be using some Amazon nomenclature. So for those who don't know, a VM is known as an instance, and a data center in a region is known as an availability zone, or an AZ. So our platform is 100% GNU Linux. I love that fact, it's awesome. No free BSD either, I'm sorry, all Linux. And we use free technologies. So to give you a bit of a rundown on what our product is comprised of, we have dedicated balancers where we'll have an active and a passive balancer. On those bales we'll have Varnish to do content caching and Nginx to do SSL termination and load balancing between web nodes. Our web nodes are, of course, running the Apache web server with PHP fast CGI currently. For our DB, we use Percona, which is a fork of MySQL. The reason we use Percona is it's, number one, patched, which is nice for security and bug fixes. And out of all the forks of MySQL, at the time we chose, it was one of the closest matches to MySQL, so it made it easy for us. And of course for our file system replication we use GlusterFS. So our range of products is pretty varied. We go from everything right on a single server which has web on it, it's got a DB, and of course we just use local disk for storage. If you've ever been to soundwave.com, that's on us. It's kind of cool. So that's one of the products. We've then break out into an HA environment where we have what's called a dedicated pair, where basically you've got two machines that are identical, both are running web nodes, both are running DB, both are running basically a Gluster. So we've got the file replication, you get the DB replication, and you've got two web nodes as part of your pool, which is great. So if a single server dies, you've still got all of your stuff on your second server. From there, because we've designed our system to be entirely modular and we can just take a web component and make a purely web server, we can break out the web component, leaving you with a database and file system with as many web nodes as you need to support your site. And of course, from there, we can break up an FSDB into purely an FS server and a DB server. So right from the beginning, and I believe the very first patch to our hosting code was to create all these different web server classes, or all these different server classes. So the fully HA environment, we run Warner Music. We're very proud of that partnership with them. And yeah, they've got quite a large site. And if that's still not good enough for you, we even go to multi-region, where you have fully HA servers in, for instance, US East and a set in EU West. We do that for Al Jazeera and running their blog sites. So, getting to the crux of the talk, which is making hardware someone else's problem. So, the total cost of ownership for hardware is actually, well, it's pretty expensive. Because not only do you have the hardware costs, you've got the power costs. And with that comes cooling. Cooling is a very big part. And there's also your time to administer the servers and to deal with any issues that arise. Surely your time is better spent doing dev work. And there's also the cost of outages, which I don't believe too many people really give too much thought or prior thought to until it actually happens. And the cost of outage is, even if with your hardware provider that you're getting your service through, you have a 24/7 contract, there's the time the outage actually happens, the time to diagnose the fault, the time for a tech to come out to your place of work. You've then got to actually get the parts sourced and installed. You then got to install those parts, boot your system. Hopefully there's no data integrity issues where you have to FSCK a multi-terabyte array. So you've got a very long, potentially, a very long mean time to recovery. Just because you use new servers and new hardware doesn't mean you're exempt from failure. And just because you may run for 2 years without an outage, what happens when you have an outage? If you're down for a day or two, it's no bueno, it's no good. So you've also got the capacity for development. That's having a development environment running 24/7 when you're only using it during the day, there's lost dollars. And also, have it if your boss comes to you, I want to spin up a new web server just to test this new thing. Well, you've got to have the hardware purchased all ready to go for that. So there's extra cost there. So we make hardware someone else's problem, but the thing is, it's still your problem though. You're paying to use someone else's hardware, you are not exempt from failure. So I just want to make that really clear. A server down is still a server down. So if you were to break out into the cloud, and there's a few questions you should probably ask, and one is, what happens when a server does go down in the cloud? Well, there's a few questions you should think about with your platform. What we've found is there's generally two types of failures. You've got an instance failure, which is where there's an issue with the virtual machine, as it were, where that dies. One such occasion is if, for instance, you're running a 32-bit Ubuntu Hardy AMI, there is a known bug where I think it's memory corruption and the server will just lock up. So you'll have to issue a reset command and your rebooter and your server will come back. Second type of failure is a bit more impacting, and that is a system failure, which is where the underlying server that's running fails. This brings up a couple of sticky points. Number one, you cannot shut down your instance. You cannot reboot your instance because the underlying hardware cannot actually do that to the service. There's also no guarantee that you're going to get that server back in any expedient time frame. So what we do to get around this is we have all of our important data on elastic block storage. So if there is a system failure, we can detach the storage from that instance, fire up another instance, plug in the disks, and we can get the server back up and running in a relatively short amount of time. What happens if you actually have a disk issue? Is there anyone here who's dealt with like a fiber channel array being down or faulty disks? Okay, that's a lot of people. Okay, to those who haven't had it happen to you, what happens is the kernel will block. There's the input-output queue, and if basically that queue has not been processed, everything else stops. It gets cached and queued and will not be acted upon until that IO queue has been, well, processed properly. So that's not really so good because just say you've got a database server where you've got a faulty disk. Your web server tries to actually run some SQL, contacts the server, gets no response. So web sits there waiting and waiting and waiting, which means that after a while it's going to get a backlog of things that it's got to be processing, but it's not going to because its IO operation has not been finished. So you eventually get your entire site locking up. Easy way to get around this is to fence. You need to have a fencing mechanism on whatever platform you have. So that if there is an issue with a single host, just say it's a database server over here, all of your webs and such over here, you say where the destination is that IP address, reject. Don't drop, just reject it. That way the webs or whatever servers can actually fail gracefully rather than waiting for a timeout, because that may not come for many minutes. There are also network issues that you've got to think about. IaaS providers use public network connections between regions. So between their data centers or AZs, they'll have their own private network set up. But between regions and to the rest of the world, it's going through public networks, which are horrendously unreliable. We have seen deprioritization of RCMP at times, which may sound really drastic, and it's kind of when you're looking at the monitoring and such, you'll see a lot of hosts down, but it's just ICMP. It's not the end of the world. Personally, I'd rather my TCP packets that are maintaining my SSH session and HTTPS connections, I'd rather they get through and actually make it to the other end and drop a few ICMP packets. And the last one of all is what happens when a data center goes down. Well, I hold 2 records with Acquia. Neither of them are really that good. The first one is it took me 53 hours to get from Adelaide to Boston. That was painful. The second one is the best first on-call weekend ever. So I've been working for them for about 6 or so weeks, and it was my time to do an on-call rotation through the weekend. So I logged in a Saturday morning, which is Boston night time, and logged in, got everything set up, cool, checked in, not many servers going crazy, so things are good. All right, first on-call's gone pretty good. Less than 10 minutes later, the alert panel goes all red and then all black. We've got hundreds of hosts showing as down. They lost the data center. Amazon lost the data center. I think it was when lightning hit them. Yeah, so we had a number of sites down. Now, for technical reasons, we don't automate the failover with our balancers. We like to keep that manual because there can be many situations that may cause a false positive. So we had many of our active BALs in the affected region. First thing we do, fail over the balancer to the passive. Yes, it's got a cold cache, but yes, it works, which is awesome. So now we've actually been able to get the balancers back. We can actually start serving sites again because we just use an EIP, the elastic IP. We just move it from one server to another, and by the magic of networking, it just routes to the second machine. Awesome, we've got some of our sites back. In this outage, we also had disk subsystem issues. That was awesome because all of our DBs and file servers were blocking. So we had to put in fencing to try and isolate them and get them out of the way to bring everyone's site back. I'm proud to say that in this outage that we were able to get on top of all this, and because of the way we have our servers set up, everything is modular and we can get to it like this, we were able to restore service to all of our customers, have everyone available again, maybe not highly available. We got back before Netflix. But not just before Netflix, we got back hours before Netflix had recovered. They were still down while we were still running. So the moral of the story is HA. Have 2 of everything and make sure you put it in different data centers. I really don't want to have to read another story about a guy who on AWS was running a single server, running life-critical heart monitoring application, and his server went down and he only had, like I said, no HA. I really hope no one was impacted by that. So yeah, there are many traps, but there are things you can do to, of course, minimize the impact. Number 1 is go through exercise of risk management. Number 2 is have decent monitoring. Invest plenty of time in monitoring. It's better to have too much than not enough. Because you can no longer see the diagnostics panel on the front of the server. You can no longer see the LEDs on your hard disks. You can't hear the BIOS beeps or anything. You've got no eyes and ears. Monitoring is the only way you're getting information. So we started off having dedicated Nagios servers, and they would, of course, poll all the clients. But that wasn't very efficient, and there was also limits on what information we could get from the clients. So we moved to using Nagios as a service. So we have a central Nagios server. There is a client daemon called NRPE, the Nagios Remote Plugin Executor, running on all of your hardware. And that Mon server to contact the host and say, give me your load graphs, and give me your disk usage, or give me your current database connections. And the client processes it and sends it back to the central Nagios server. And that worked really well. We're able to scale out to manage, well, to be able to monitor 100 servers from a single Nagios box. CheckMK is a nice GUI front end that can actually handle the consolidation of many Nagios servers into the one easy-to-use web interface. You can do RRD graphing with it, which is great for being able to show load over time, like CPU idle, etc. You can graph all of that with CheckMK. It uses a service called Live Status. Live Status is essentially running on all of your monitoring servers, and it is pulling data from Nagios and formatting it in a way that CheckMK understands. Now, the last one up there is Live Check. The thing about Nagios is it is single-threaded. So when I said we could only monitor 100 servers, that was the limit, because we'd send off another check and would have our queue waiting for the response to come back. So the I/O of these servers was just saturated. Live Check forks. So we can now run tests in parallel, which meant that we've been able to go up to 250 servers per mon server. And by our most recent calculations, we should be able to monitor about 400 servers per mon. This means we don't have to run as many mon servers, which of course is optimizing and economizing on the amount of money we're spending on infrastructure. So to give you the bit of, basically that's the overview of how we have our monitoring set up. Yeah, we have a central CheckMK server purely about pulling stats and having a look at the information, being a bit of a user front end. Multiple mon servers, and then of course multiple end user servers. To make the most of monitoring setup, you need to actually be able to get that data easily. We've used a product called Nagstamon, which works really well. It can plug into CheckMK and into Nagios and show you in a nice Python application the alerts which are currently going off. You can do alert filtering, so you can filter out all of your warnings or just show the criticals. You can also, if there's particular servers who are ticking you off, you can ignore them completely. It makes a nice front end. Also, it does audible and visual alerts. If you haven't seen it before, definitely recommend giving it a look. So yeah, the big point of moving to the cloud is, and actually even with any systems, is making sure you've got automation down pat. The less actual legwork that you have to do, going, clicking your mouse or executing scripts, the better it is, not only for you, but also for the speed to recovery, because I'm pretty sure that computers can, well, process commands a lot quicker than human beings. So we developed a code base purely for the management of all of our servers. Like I said, the very first code commit was defining what is a web, a database, file server, so on and so forth. It was originally coded in PHP because that's what the programmers knew, but we've made the move to Ruby for many reasons. Well, Ruby and Puppet seem to get along quite nicely, and also had a few engineers who have previously dealt with Ruby. There's also a third reason, that is that there is a module known as the Fog Gem, which is a module for controlling multiple IaaS providers. So with the same code base, we could, in theory, spin up servers with rack space or with any other provider without having to modify too much of our code. So as we go into the future and we diversify, even if we decide to run our own private cloud, we can still use the same code base with minimal re-engineering. So another thing that, so I'll get to the Puppet there, that back in 2007 when we first started, Puppet was pretty immature, but was being actively developed. At the time, Chef was infantile, so nowhere near ready for production use. I understand there are other systems. Whatever works. You should choose a product that suits your needs. And yeah, so with Puppet, you can have, like you break it up into individual recipes, and depending on what your server needs, you can just apply those recipes. So yeah, and that's really sort of the crux of the talk. So.